The numerous medical benefits of printing three-dimensional, opaque, or colored medical molds and models can be accomplished through binder jetting technology. At Walter Reed National Military Medical Center, technicians design objects which include veins, arteries, and other pathology where color can emphasize a distinct anatomical feature. Binder jetting printers use two materials: a powder, typically gypsum, and a binder. Once the technician loads the model from an external software program, the printing process begins on a platform of layered powder. Multiple print heads move horizontally along the X and Y axis of the build surface, applying a bonding agent and color to the powder. As the material hardens, the platform lowers and a new layer of gypsum is drawn across the bed. Throughout this process, the object is self-supported within the powder bed. And once the part is completed, the remaining unbound material can be eliminated with a vacuum and then recycled. Upon removing the fragile model from the bed, the operator clears away most of the surface powder by using a brush or a vacuum. Then, any remaining residual material is blown off with compressed air inside an enclosed chamber. Once this process is completed, the brittle surface is hardened by applying a layer of cyanoacrylate, a strong, fast-acting adhesive, over the entire object. Due to the sensitive nature of the binding materials utilized in binder jetting technology, these systems are best suited to service patients by the fabrication of molds for facial prostheses, as well as supporting providers through the building of colored anatomical training models and medical simulators. Material jetting is another type of three-dimensional printing system which has a multitude of applications within the realm of military medicine. This process creates patient-specific anatomical models with a drop-on-demand method that incorporates materials of different colors, transparencies, and flexibilities into the build. After the operator sends the object to the printer from a standalone computer system, the print heads begin to apply the photopolymer material. This light-activated resin is jetted, sprayed, or extruded horizontally along the X and Y axis onto the build surface. Meanwhile, high-intensity ultraviolet lights cure the layer, allowing the polymer to quickly transition from liquid to solid. In order to integrate special features, several different materials are mixed together during the build to obtain new substances consisting of all various hues, opacities, or even hardness. As the printing process continues, each new layer bonds to the previous one until the object is complete. A technician then removes the model from the build platform, and the temporary supports can be detached by hand through the use of a pressure washer or in a bath of basic solution. Once all the supports are eliminated, any transparent items are coated with resin or another transparent material, then polished by hand. Next, the models are allowed to cure or set. This ensures the final product achieves optimal visualization properties. Because material jetting can accommodate multiple materials within an individual build, it's an extremely useful printer at the 3D Medical Applications Center. Technicians incorporate distinct external and internal anatomy, such as metal hardware, teeth roots, and tumors. These features provide a visual reference which aid medical personnel in pre-fitting devices for both routine and highly complex surgical procedures. At its foundation, material extrusion printing is a combination of extreme heat, constant pressure, and a sturdy thermoplastic polymer. This process, also known as fused deposition modeling, enables the 3D Medical Applications Center to create plastic medical parts and devices, which are generally more durable than most common photopolymer or gypsum products. Material extrusion works like a very complicated glue gun. After the operator loads a new platform and inputs the build commands, a line of acrylonitrile butadiene styrene or another thermoplastic material is drawn from a spool and converges with a string of white support filament at a heating element. The two are independently extruded with constant pressure through nozzles that move in both X and Y horizontal directions. Meanwhile, the support platform lowers vertically after each new cross-section is bonded onto the previous layers. Once the print is complete, the part and platform are removed from the machine. Depending on materials, the object is either placed in a bath of alkaline solution to dissolve the remaining supports, or the technician may break away the support filament by hand. After the model has soaked, the part is removed, rinsed in a water bath, and allowed to air dry. Material extrusion printing is a valuable asset in military medicine. Its strong and versatile materials are used by technicians to manufacture customized prosthetic device prototypes and assistive technology, which help enhance everyday activities for many individuals. The only printing system at Walter Reed National Military Medical Center that manufactures three-dimensional objects by melting metal alloys is powder bed fusion, or electron beam melting. By achieving temperatures that can reach up to 3,000 degrees Fahrenheit, this process fabricates the strongest custom componentry for amputees, as well as surgical guides, instruments, and specialized implants. Once the technician loads the print file, the platform and powder bed are carefully leveled by hand, and the chamber is prepped for the build. Powder bed fusion melts metal powder like titanium or polymers like nylon together in layers or cross-sections that are fused with an electron beam, laser, or other heat source in a controlled environment. The printing process begins with a fine blade spreading a thin layer of powder over the platform from a reservoir of fresh material. As the printing platform lowers, each cross-section is essentially welded or melted to the preceding layers until the build is complete. After a cooling period, the manufactured parts, which are encapsulated in a block of lightly sintered powder, are removed from the printing platform. Any titanium objects must be first freed from the unfused powder by blasting the block with air and other fine materials. Once the models are recovered, the technician extracts any prefabricated supports. This is followed by a grinding and polishing process, which removes any residual material. Finally, the parts are ready for use, after each piece is meticulously cleaned with bead blasting and ultrasonically washed. Because powder bed fusion is capable of creating extremely sturdy and uncompromising metal parts, it is a vital asset at the 3D Medical Applications Center. This technology enables the design of custom titanium implants for craniofacial injuries and revolutionary metal orthopedic prosthetic devices for patients, which can directly improve their quality of life. One of the several types of industrial 3D printing technologies employed at Walter Reed National Military Medical Center is VAT photopolymerization, also known as stereolithography. These machines use various polymers to create solid, plastic, three-dimensional objects from medical scans or 3D designs in a matter of hours to days. The process begins inside a vat of light-sensitive photopolymer resin. Once the technician engages the printer, the model is gradually constructed layer by layer using an ultraviolet laser or a projected image. With each pass, less than 1/8 of a millimeter of resin is cured. Since no structural support is provided from the material during the build phase, additional fabricated lattice structures are included within the print file. After each new layer is bonded together, the platform lowers the object into the vat, exposing a fresh area of resin. Once the object is printed, it's transferred to a parts washer for cleaning. After this cycle is complete, the technician removes the model and sprays off any remaining surface residue in an adjoining vat. Next, all of the supports generated during fabrication are then removed by hand. And the object is placed in a chamber with special lights. This ensures any remaining post-build resin is cured so the model can be handled. In addition, there are smaller stereolithography machines which can easily be relocated if necessary due to their compact size. Many of these tabletop 3D printers have interchangeable resin vats, which enables technicians the opportunity to switch materials within minutes. Because the smaller systems support several types of polymers, objects can be created with different physical and mechanical properties. Another singular aspect of this type of 3D printer is that the objects are printed upside down, thus providing a unique perspective of this resin-based process. While VAT photopolymerization printers come in different shapes and sizes, they all fill a vital role in military medicine. The numerous polymers they offer are well suited for the various specialty requirements from doctors. From true-to-scale physical models to custom dental devices, these items can be handled and manipulated prior to treatment, which is beneficial for medical professionals and patients alike.